Hello everyone, I'm Frank and welcome to Frank Learn How to Sudoku. Sorry, about to say Frank Puzzles. This is the very easy version where we learn how to Sudoku is where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Lumberjack Stihl Timbersports by Will Power. And here are the rules. We have normal Sudoku rules apply. I think it's a misspelling. It's supposed to, or mistyping. I think it's just supposed to be normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have German whispers, where numbers on green lines, which is the saw, are at least 5 apart from their neighbors on the line. And we have Dutch whisper lines, where numbers on the red line, which is the log, which is where we're cutting, are at least 4 apart from their neighbors on the line. And I will be calling them Whisper 5 and Whisper 4 lines respectively, because I think it's very easily extensible. And a setter came up with that name, and I thought it was brilliant because of the way that it just easily extended, right? You could have Whisper 3 lines, Whisper 6 lines, Whisper 7 lines, etc., etc. Whereas I don't know how you go expand from German and Dutch. Maybe you go to Belgium, I guess, or I don't know, Luxembourg. That's Actually, I don't think that's neighboring. It might be neighboring Netherlands. I don't know. Either ways, but how do you expand from those whispers? It's not as easy to. Anyways, but know when I'm saying whisper 5 and whisper 4 lines, it is the same as German whisper and Dutch whisper lines. So as an example, say this was a 3. Then these digits on this whisper 4 line would have to be 7, 8, or 9 because those are the only digits which are 4 or more away from 3. And this digit would have to be 8 or 9 because this digit has to be, those are the only digits 5 or more away from 3. And that's an example of how whisper 4 and whisper 5 lines work. Numbers in cages sum to 10. So, for example, if this were, say, a 3 here, this would have to be 7 because these must add up to 10. And that's for all killer cages here. So these must add up to 10, these must add up to 10, these must add up to 10, and these must add up to 10, etc., etc. We finally also have crop key pairs, where numbers with a white dot between them are consecutive, and numbers with a black dot between them are in a ratio of 2 to 1. And not all dots are shown. Not all possible dots are shown, sorry. And the oval on the saw handle does not affect the puzzle. It's just to show that this is a saw, where you're sawing through a log. As examples, say this was an 8 here. This would have to be 7 or 9 here to be consecutive with it. And say this was a 2 here. This would have to be 1 or 4 to maintain the 1 to 2 ratio that is between these digits. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, where should we start here? Let's start with the upper part of the saw. And what I like doing, particularly in Whisper 5 lines, is on a Whisper 5 line, you'll always alternate between low digits and high digits on a Whisper 5 line. And the low digits being 1 through 4, the high digits being 6 through 9, with 5 not being allowed on a Whisper 5 line. So, how do you know 5 can't be on a Whisper 5 line? Well, if you subtract 5 or more from 5, you get 0 or less, which is not a normal Sudoku digit. If you add 5 or more to 5, you get 10 or more, which is not a digit. So that's why 5 cannot be on a Whisper 5 line. And how do you know that you alternate between low and high digits on a Whisper 5 line? It's because if you have 1 through 4, which are the low digits, what digits can be next to it? 1 can be next to 6 through 9, 2 can be next to 7 through 9, 3 can be next to 8 or 9, and 4 can only be next to 9, all of which are high digits. And what digits can be next to a high digit, which is 6 through 9? 6 can be next to 1, 7 can be next to 1 or 2, 8 can be next to 1 through 3, and 9 can be next to 1 through 4, all of which are low digits. So therefore, on a Whisper 5 line, you'll always alternate between low and high digits. So if we choose one set and say this is going to be a certain color, we know the neighbors to it have to be the opposite color. And then you'll alternate back and forth between those colors. So let's just make this orange and we'll make this pink. So since this is orange, this is pink, this must be orange, this must be pink, this must be orange, this must be pink. This is orange here. Sorry, since this is orange, this is pink here. These are pink, which forces these to be orange, which forces this to be pink and pink here. This is pink, this can't be, this must be orange, which makes this pink. Actually, let's make this not pink. Let's make this yellow. So we'll make those yellow. To be next to a digit that is either high or low, it's got to be another high. If it's high digit, it has to be high or 5. If it's a low digit, it must be next to low or 5. Either way, it's going to be either the same set, which is yellow, or a 5, which I usually mark as pink cells. Okay. These digits, first, these digits are 5 or more away from each other, and they add up to 10. So therefore, the only ones that satisfy that, 3 and 7 don't satisfy it, 4 and 6 don't satisfy it. The only ones that satisfy it are 1, 9, and 2, 8. That means, this is 1, 2, 8, 9. Both of these digits are next to 2 unique digits on the Whisper 5 line. But they cannot be 1, 2, 8, or 9 because of the 1, 2, 8, 9 quadruplets in the box. Well, we know 4 and 6 can only be next to 1 unique digit, so this has to be a 3, 7 pair here. That means the remaining digits in this box have to be 4, 5, and 6. These add up to 10. This is yellow, so that must be with orange here. And this cannot be the same as 3, 7, and it cannot be 1, 2, 8, or 9. And it's next to a 3 or 7 here. So this must be the other 1, 2, 8, or 9 here. Because 3 can only be next to 8 or 9. 7 can only be next to 1 or 2. So this pair cannot be the same as this. Obviously can't be 3, 7 as a pair because these two eliminate 3, 7 as a possibility here. So this digit is the same as that. This digit is the same as that. Let's mark those as letters. So we have A and Z are the same. Where are 3 and... Interesting. We don't have any information here. Okay. Oh, these have to be opposite, right? Sets. Which means you're going to have a low digit here and a high digit here, or a high digit here and a low digit here, next to the same number. And the only way that works is if this is 5, and this has to be 1 and 9 here. Because if you try any other combination, it just doesn't work, right? If you try to have another low digit here, say this was high and we had a low digit here. Well, the problem is a low digit is not going to be 4 or more away from another low digit. And it works the same if this is high and low here. The high digit, 6 through 9, is not 4 or more away from another high digit. So this is guaranteed then to have to be 5. And this is pink, which means this can't be pink here. So this is yellow and yellow. So 5 has to be next to 1 and 9. Therefore, this cannot be a 1-9 pair, because if this is 1 and 9 as a pair, that would eliminate all possibilities for this cell. So this has to be a 2-8 pair, which makes this a 2-8 pair. This can't be 2 or 8. It's 1 or 9 here. Yeah, we don't need the A and Z anymore because we know this is 2 and 8. And the reason why this can't be 1 and 9 is because this pair... Sorry, this has to be 1 and 9, because if this tried to make that 2 and 8, it would eliminate all possibilities for that cell there. So this cannot be 1 and 9. It cannot be 2 and 8. It's either 3, 7 or 4, 6 here, adding up to 10. 2 and 8 cannot be here. This digit is next to both 1, 9 and 2, 8 of the yellow. And it cannot be the orange 1, 9. So this is either 2, 8 or 3, 7 for orange. This yellow cannot be the yellow 1, 9 here. So it could be 2, 8, 3, 7, or 4, 6. These are consecutive, and this can't be 1 or 9. So this is also 2, 8, 3, 7, or 4, 6. And same with this. And this cannot be the yellow 2, 8, because this is the yellow 2, 8 here. So this has to be 3, 7, or 4, 6 here. Well, we have a yellow 2, 3, 4, 6, 7, 8 triplet here. So this is either going to be 2, 3, 4, or it's going to be 6, 7, 8 here. Well, if these are consecutive, we are guaranteed that if this is 2, 3, 4, this is 3 with something. And if this is 6, 7, 8, this is 7 with 6 or 8. So this can't be 3 or 7 here. This is 2 or 8 or 4 or 6 here. We're not sure which. Either way, this digit has to be next to, at minimum, 2 and 3 or 7 and 8. Or maximum 7 or 8. If it's 2 and 3 here, this has to be 8 or 9. And if it's 6, 7, and 8 here, this has to be at minimum 1 and 2. So this is 1, 2, 8, and 9 as an orange. We're not sure which. This is 1 or 9. So this is orange, which means this must be yellow, or it's 5. We don't know. This is orange, and it cannot be 5 here, because 5 plus 5 adds up to 10, but then we'd have a duplicate in the row. So this has to be orange, which since this is orange, this must be yellow. That means this can't be yellow. This is orange, which means this can't be orange. It's yellow. We have orange there. This is yellow, and this is orange. So we have 2 oranges here. This is at least 4 apart. So if this is orange, it could be 1, 9, but this would have to be yellow or pink. And it cannot be pink because 5 cannot be next to a black Kropke dot. If you have 5, you get 2.5. If you double 5, you get 10, neither of which are digits. So this cannot be 5. It has to be a yellow here. So this is a yellow, yellow, which means all the yellows, you can't have 2 high digits be in a 1-to-2 ratio with each other. So all the yellows must be low. So these are all low. The oranges are all highs. And this must be in a 1-to-2 ratio. This is then 1. This is 9. This has to be 7 or 8. This has to be 8 or 9. This has to be 3 here with... So this is either... This is 2. We have 2 here, 2 here, 8 here, 8 here. No 6 or 8, 2 or 4. This is 3 with 2 or 4 here. This could be 5 or it's low. 2 eliminates 2 as a possibility here again, so this is one of these is 3. This is 1 because it's low, and that's 9. This has to be 7, and that's 3. Okay. We don't know anything there. This is 7 or 8. This has to be, cannot be, okay, so these two add up to 10. So this is the low, and it cannot be 1 or 3. So this must be 2 or 4 here. That leaves this as 6 or 8 here to add up to 10. We have a 2, 3, 4 triplet now in row 5, which limits 2, 3, 4 in the rest of the row. So these are all high and are 6, 7, 8. Therefore, 7 has, this is 6, 7, 8 as a triplet in this left central box. That eliminates 6, 7, 8 in the rest of the box, so we have to have a 7 here. So this cannot be 7 there. This has to be 1 through 5, cannot be 2, 3, or 4, so this is 1 or 5 here. This is, if this were 6, this would have to be 1, which would make that 2. If this is 8, so if this is 6, this is 1. If this is 8, it could be 1, 2, or 3. Eight would have to be 1. So if this is 8 and 1, you can't have 8 and 1 here. It would have to be 8 with 2 or 3 here. 3 would have to be 6 here, but 6 and 8 are not 4 apart from each other, so this couldn't be 3. So we know one of these is a 2. If this is 8, this is 2, and then this would have to be 4 to be or 1. So this is 1, 2 with 1 or 4 here. But we know one of these is 2. Okay. These two digits, well, we don't have very much information there. This is high. That means this is low or 5 here. These have to be 4 apart from each other and add up to 10. Obviously cannot be 2, 3, 5. Can't be 1, 3, 6 or 1, 4, 5. It has to be 1, 2, and 7. So 7 has to be in the middle. So this is high, which is next to low and low. And these have to be 5, 7, 1, 2. That eliminates 7 in 1, 2 in the rest of the box. So this pair of digits adding up to 10 cannot contain 1, 2, or 7, which eliminates 1, 9, 2, 8, and 3, 7. So this must be 4, 6 as a pair. So this is 7. This can't be 1 because of 1 in the column. So this is 2, which makes that 1. 4 and 6 are consecutive with 3 or 5 here. So this is 3 or 5. This is 1, which makes this a high or 5 digit. 2 here forces this to be, cannot be 6 because of, and this can't be 4, 6 because of the 4, 6 pair in the row. So this must be either 1, 3 or 7, 9 to add up. And the reason is we already have a 2 in the box, so this can't be 2, 8. This can't be 4, 6 because of the 4, 6 pair in the row. 7 eliminates 7 from being here, so this can't be 3 to add up to 10 with it. This is higher 5. It can be 5, no 6, no 7, or 8 and a 9 there. This can't be 2, 8. So it has to be either 1, 9, 3, 7, or 4, 6. No 1 here, so this can't be 9 there. No 3 here because of 3 in the column, so this can't be 7 there. We don't know. So if this is low as 1, this can be specifically, if this is 1, this has to be 5 through 9. If this is 5, it has to be specifically 1 or 9 here. This can't be 7 because of 7 in the column. Okay. This digit cannot be 7. It's next to two unique digits on the Whisper 5 line, so this must be 8 or 9. This digit cannot be 6 because of the 4-6 pair in the row. And it has to be high, 7, 8, 9. We have a 7, 8, 9. Actually, these are all low. So since this is low, we have 4 lows already in the box. This has to be a 5, 6 pair. And this digit is next to two unique digits on a Whisper 5 line. So it cannot be 4. 4 can only be next to one unique digit. So therefore, it can't be 1, 2 because of 1, 2 in the row. So this is 3, which makes this 1 and 9. That makes this 8. That makes that 7. 1 eliminates 1 here, so that's 2, which makes this 4. 4 eliminates 4 here. So this is 2 and 8 adding up to 10. That eliminates 8 here because of 8 in the box. So this can't be 6 because of the 6, 7 pair in the row. So this is 8 here. 8 eliminates 8 here, so that's 9. This cannot be 2 because of the 2 in the row. So this is a 3, 4 pair, which eliminates 3 and 4 in the rest of the box here. So this is 2. 9 eliminates 9 as possibilities here. This digit cannot be 5, 6, or 8 because none of those are 4 or more away from 5 or 8. So this has to be 1. So this is 1, which makes this a 5. So it's not low. That's 5. This can't be 5. It's 8. That leaves this as a low here. This cannot be 1 and 9, adding up to 10. This can't be 1 or 9. Because if it's 1, so this can't be 1 or 9, so this cannot add up to with another 1 or 9 adding up to 10. So this must be 3, 7, 4, 6. This is 3, 7, 4, 6, and this is 3, 7, 4, 6. No 7 here, so this can't be 3. That 3, 4, 6, 7 triplet or quadruplet eliminates 3, 4, 6, 7 in the rest of the box. 1 can't be here, so that means 1 has to be here. This is then 5, 9 as a pair, which eliminates 5, 9 in the rest of the column. This can't be 5, it's 3. That leaves the remaining digits in row 8 as a 2, 5 pair. 3 is consecutive only with 4 out of 4 and 6. So that's 4, that's 6. That eliminates 4 here, which means these can't be 6 here. 4 eliminates 4, 6 as a pair, adding up to 10 here. So this is 3 and 7. Remaining digits of row 8, again, are 2 and 5. This 2 eliminates 2 as a possibility there, so it's 5 and 2. 3 eliminates 3 as a possibility here, so it's 4 and 3. This can't be 5 because of 5 in the column. No 4 or 5 here, so that's 6 there. This can't be 4 and 6 because that would eliminate all possibilities for that cell there. So then this is 7, 3. This is 6, 4. No 4, 6 here. 6 eliminates 6 here, so it's 4. 4 and 6 eliminate 4 and 6 here, so it's 5. 5 eliminates 5 here, so that's 9, which makes that 5. So to add up to 10 here, this has to be 3 and 7. This can't be 7 because of 7 in the column, so that's 3 and 7, which leaves remaining digit in row 1 as a 1. Remaining digit in column 7 is a 6, which makes that not 6, so it's 5 and 6 there. 6 eliminates 6 here, so it's 7 and 6. 7 here eliminates 7 here, so that's 8. Remaining digits in row 9 are 4 and 9. This can't be 9 because of 9 in the column, so it's 4 and 9 there, which leaves this digit as 7. Remaining digits of column 9 are 1 and 6. Okay, that doesn't give us that much, interestingly enough. I was kind of surprised there. Remaining digits of column 5 are 2 and 9, and 2 can't be here because of 2 in the row, so that's 9, that's 2 there. Remaining digits of row 7, and I'm just basically just doing normal Sudoku now. Though, actually, let's do this one. This adds up to 10. Well, I'm curious if we get that even without using that. Let's try it. Remaining digits of row 7 are 5 and 8. This can't be 5 because of 5 in the column, so that's 8 and 5. Remaining digits of column 4 are 4 and 6. as a pair. Remaining digits of column 6 are 1 and 3 as a pair. Interesting. Remaining digits of row 2 are 2, 4, 9. And this cannot be 2 or 4 because of 2 or 4 in the column. So this is 9. This can't be 2 because of 2 in the column. So this is 4, which makes that 2. Remaining digits of row 3 are 5, 6, and 8. This cannot be 5 or 8 because of 5 or 8 in the column. So that's 6, which leaves this as a 5, 8 pair. And probably we do need this, but let's just check. Remaining digits of column 3 has to be a 1. So 1 here eliminates 1 here, so that's 3 and 1. It also eliminates 1 here, so it's 6 and 1. 6 eliminates 6 here, so it's 4 and 6. Remaining digits of row 4 are 5 and 7. And this can't be 7 because of 7 in the column, so it's 5, that's 7. That's not right. I did something wrong. Oh. This is not 1 and 3. That's the problem. Okay. So this is 3 and 7. Well, this can't be 7 because of 7 in the row, so this is 3, that's 7. Apologies for that. I messed that up pretty badly. This still has to be 1, which makes this 6 and 1. 6 eliminates 6 here, so it's 4 and 6. Remaining digits of row 4 are 3 and 5. This can't be 3 because of 3 in the column, so it's 5 and 3. We didn't actually need this 10 here. 5 eliminates 5 here, so it's 8 and 5, which leaves this as a 4 and this as a 9. Interesting. So we actually didn't need this cage here. I guess it was kind of extraneous. Maybe we didn't need this cage either. I'm kind of curious about that, but maybe we had to have one of them, I guess is the point. But we definitely didn't, since we solved using this one, we definitely didn't need this cage. So I don't know. Maybe, I don't know. It's an extra chip that's being sawed away. I'm not sure. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.